Hi there, I'm Andrew, and welcome to a step-by-step guide on how to physics, because Mr. Wilkins will not teach you. Now, you're probably asking yourself, what are the three things to physics? And you see, I'm getting there. Hold that thought. Sorry about that. I have this is my Zoom class right now. Anyway, we have the first law, second law, and third law, and possibly don't forget to stay hydrated.
Your mom's a geophysicist.
I don't care. Now, you're probably asking yourself, what is the first law? The first law is defined by Newton, and basically what it is any object that is in motion or even at rest will stay in motion or at rest until some force is acted upon by it. So, if you're going at constant speed and you have no force acting on it, you're going to go at constant speed. Now, do keep in mind, that's kind of impossible to replicate due to the fact that friction and the force of gravity always will apply. If you had some frictionless object or material out there, please let me know, but I don't think you can unless you use like air, but I don't have that kind of equipment. So, yeah. All right. So, now our first demonstration of this first law is this muscle torn up roller thing. It's, it's pretty bad, but that's what I have. Notice how right now it's in motion, or it's not in motion, sorry, it is at rest. The only force acting on it right now is the force of gravity and the normal force. This object right now is balanced. It's going to stay in motion, or in motion, and the motion is basically zero. It has zero acceleration, so it has zero force at that point because F equals ma. However, if I apply some force on it, then it becomes unbalanced in the x direction, and it will cause it to fall. Now, there are a few things out there that will cause it to do that magically. You just have to think really hard. Like that. Thank you. That's my Roomba, by the way. Get good. So, now with that demo done, we're on to the second law. But before we get there, let's memorize the formula of F equals ma. And speaking of which, what does that have to do with physics? Well, fortunately for you, you have just the guy that knows everything about physics, everything. The second law is that formula itself. It's F equals ma. How do I know this? I just did a Google search. Really? I mean, yeah. But let's give you the best example in the world. Okay, so if we know that Newton's second law is F equals ma, then in theory, when we do a push-up, we should be able to create a force, because that's my mass, and I'm accelerating however much, so long as I accelerate and don't go up a constant rate. But at some point, if I go up at any point, I'm going to cause an acceleration, causing a force. So, I really am fixing to do somewhat of a push-up here. Notice that right there, I caused, and it's a gorilla push-up, leave me alone. I caused a force that I pushed against the ground, and the ground pushed against me, and because I am able to overcome that force, the harder I push against the ground, the more I can help myself, and more that I push against the ground, the ground pushes against me, allowing me to go up. Now, if I decide to sit in a plank position, in theory, at the same time and hold it, I do not create any force. Because I'm not accelerating, I'm staying in the same position. That is the difference. If I was doing a plank, I don't create any force because I'm not moving. Keep in mind that in the first law, if I am at rest and there's no force acting against me, I'm going to stay in rest. And if I am in motion, that means at a constant rate and I have no force against me, I'm going to stay in motion. So, yeah, unless I have some force acted against me, in which case I have my muscles pushing against the floor, allowing me to simply go up. Like that. Now, in that demonstration, if I was to calculate the second law, I would take my mass, which is like 240, times my acceleration, and let's just say that I go up, this may not be right, but like 0.5 meters per second, but then I also go down 0.5 meters per second, there's a change by 0.5, so I would do 240 times 0.5, and then that would be my force created. But mass has to be put in newtons, so that would be times it by 10 in reality, but yeah. I know. I'm gonna chug gasoline at this point. Anyway, our third law consists of action-reaction, which basically, this is going to be normal force. Whatever force you apply against an object, it's going to have an opposite reaction. So take, for instance, this ladder. As I push against this ladder, the ladder's pushing against me, right? Or if I push against this cabinet, the cabinet's pushing against me. And so, basically, I'm going to describe this more in depth while on this balance board. Now, keep in mind, I'm a trained professional, don't do this at home. Now, basically, what this means is your normal force is going to be the opposite of whatever, gosh darn it, whatever reaction you apply. So, if you lay on the ground now, if you just stand still, the ground is pushing against you because you're pushing your weight against it. So, for example, if I was to punch somebody, not in this form, of course, but if I was to punch somebody, it would hurt because I applied a force to them, and their body applied a force back to me, that of which is the normal force. And that is basically your third law. Take, for example, this board. As I sit there and I put my weight on it, I'm applying the weight on the board, and the board is applying a weight back on me, allowing me to stand on it, and actually, surprisingly, not break. And because of this, the force that it applies back is what you call a normal force. And this happens all the time. It doesn't matter where it is. And it doesn't always have to be, force of gravity canceling out normal force. So, yeah.